Nidhi, you unmute yourself. Unmute.
अभी करवा रहे हैं यार, अभी 4:30 बज गया है, 2:30 बज गया है यार। क्या मतलब वो उनकी
use this laptop. Sound करिए पास में.
इंडियन नेशनल साइंस अकेडमी की
हाँ।
ओर से आप सभी का हार्दिक स्वागत है। नमस्कार। On behalf of INSA, I, Nidhi Kumar, extend a very warm welcome to all of you on this program today. तमसो मार्ग ज्योतिर्गमय, ये प्रार्थना है कि हम अज्ञान से ज्ञान की ओर बढ़ें। In the S20 webinar series, we will create opportunities that will have profound long-term consequences. The theme for S20 this year is Disruptive Science for Innovative and Sustainable Development. The theme reflects disruptive change and its implications for a circular economy, and it may be inventive and consistent with sustainable growth in a world that is constantly changing. With its distinctive contributions to such endeavors, India is ideally positioned to incorporate this perspective into contemporary discourse. And under this broad theme of S20 today, friends, we will focus on the role of Indian academia in the development of 6G standards spectrum to enable centers' initiatives for Atma Nirbhar Bharat. After 5G, friends, the sixth generation of 6G is the next generation telecom network that will be built upon 5G technology, providing more reliable, ultra-low latency, and affordable solutions with speeds almost 100 times faster than 5G to enhance and drive new communication applications. These technological advances will impact user experience and transform economies and lives everywhere. It will include intelligent network management and control and integrated wireless sensing and communication. The Bharat 6G Vision document, recently released by Prime Minister Narendra Modi ji, is to create a national mission for 6G, and the mission's purpose is solely to catalyze coordination and interactions between various stakeholders in center and state governments, as well as industry and academia. The fundamental applied research for 6G technologies is to create a new IP, knowledge, and skilling. And the pilot scale and validation of these technologies for international and national standards is expected from 2025 onwards. To talk on this, we are privileged to have with us two very eminent speakers, Professor Ashutosh Sharma, President INSA, former Secretary, Department of Science and Technology and Institute Chair of IIT Kanpur, and Professor Abhay Karandikar, Director, IIT Kanpur. I would first like to welcome Professor Ashutosh Sharma, President, Indian National Science Academy, Institute Chair of IIT Kanpur, and former Secretary, Department of Science and Technology. He has been the founder of the Center for Nanoscience and Center for Advanced Imaging and Chairman of Chemical Engineering, Center for Environmental Sciences, all at IIT Kanpur. He is a recipient of many scientific awards and honors, including the Infosys Prize in Engineering and Computer Science, the Shanti Swarup Bhattacharya Prize, Distinguished Alumni Awards of IITK and Sunny Buffalo, and honoris causa from several universities in India and abroad. He has helped initiate several new programs related to infrastructure and human capacity building, innovation and startups, R&D in advanced manufacturing, waste processing, clean energy, cyber physical systems, industry, academia cooperation, science communication, women scientists, and major international collaborations in the areas of priority for the nation. He's currently the president of INSA, and we hope to see INSA grow into a stellar institution under his leadership. I would like you, sir, we're very honored to have you here with us and to start the series. I would like you, sir, to share your thoughts on the importance of S20. Professor Ashutosh.
I think you need to unmute.
Unmute. Can you hear me? Can you hear me?
Yes.
Yes.
Nidhi, can you hear me?
Yes, yes.
Okay, wonderful. Thank you very much indeed. I extend a hearty welcome to all who have joined here. And indeed, our first guest, very distinguished guest, Professor Abhay Karandikar, Director IIT Kanpur. Let me just very quickly introduce to you the subject
So
matter.
we can't hear you,
S20.
sir.
Can you hear me? Abhay, can you hear me?
Yes, we
Yes,
can
yes.
all hear you.
We can.
Yeah, I think problem, Nidhi, is at your end. Okay, so I think if you and may I request everybody to please mute themselves unless we are speaking. Yeah, Nidhi, I know, I can't make you happy. You will not hear me. Okay, we can't hear you either. Dr. Banerjee, can you hear me?
Yes, we can hear you.
Okay, wonderful.
I can
Okay,
hear
so
you.
now the S20, very quick introduction and how that is related to the theme that we have today. So S20, as we know, is a vertical of G20 for which India is the president this year. So S20, which is Science 20, is driven by the science academies of the 20 member states. The theme this year chosen by India is Disruptive Science for Sustainable Development, of which there are three more verticals in this. One is related to clean and green energy. The second one is universal holistic health. Universal meaning reaching the last person, and holistic meaning not just inside the hospital setting, but everything outside of it, the well being as a whole. And the third theme is related to connecting science to society and culture. So if we look at the disruptive science on the horizon, the disruptive science is all about the digital science, the rise of it, which is in communication, that we would talk about today, 6G, communication, getting together with computing, getting together with decision making that is autonomous through artificial intelligence, machine learning, and so on. So, future of technology and indeed of humankind is all about convergence of different streams of technology. And a very compelling aspect of that is communication, going beyond 5G over to 6G. And this is such an important aspect, whether it is all present communication everywhere. It's not only about the speed of communication, it's not only about the stability, but it's about connecting everything which is there. Communication and computing in everything, whether it is IoT, whether it is any kind of machines and everything. So it's not just human to human communication, but it is about connecting everything, and then having a smart world, which is not possible without communication of the kind 6G and beyond. So I welcome again everybody, especially our guest, Dr. Karandikar, and then let us get started talking about the future, in particular about the future of communication, the 6G. So Nidhi, can you hear me now, and can you take
Yes.
over?
Yes, sir. Thank you so much for sharing your thoughts on the convergence of technologies and how important that would be for India and the future of science and technology. It is indeed my privilege now to welcome amidst us today Professor Abhay Karandikar, Director IIT Kanpur. Professor Abhay Karandikar is currently serving as Director of IIT Kanpur. Earlier, he was the Dean, Faculty Affairs and the Institute Chair Professor in the Department of Electrical Engineering at IIT Bombay. He has been instrumental in developing many path-breaking technologies and has been at the forefront of several large initiatives, both at the institute and at the national level. He's the founding member and chairman of the Telecom Standards Development Society of India, India's standards body for telecom. He has also served as coordinator of Tata Teleservices, IIT Bombay Center of Excellence in Telecommunication, TICET, and the National Center of Excellence in Technology for Internal Security. Professor Karandikar received his MTech and then did his PhD in electrical engineering. Following it, he joined the High Performance Computing Group of the Center for Development of Advanced Computing. His current research interests include frugal 5G, and rural broadband device-to-device communication software, defined networking, network function virtualization, and 5G core network, and quality of service and resource allocation in wired and wireless networks. His large research group comprises research scientists, engineers, scholars, and senior managers. They have together developed path-breaking technologies. He's an Indian educator, engineer, and advisor and philosopher, best known for his work in telecommunication sector in India. He was one of the founding members of the Telecom Standards Development Society, and he's chairman to give recommendations to Government of India on size, scope, quantum of spectrum for the experimental spectrum license for 5G. He has also contributed to conceptualization and establishment of new technical standards and programs for TSDSI. He was awarded in 2016 with IEEE SA Standards Medallion for his work towards Indian technology, policy, and standardization. He's a member part-time of TRI and serves on the boards of Central Electronics Limited, National Rail and Transport Institute, and also on the board of Engineering, Science and Engineering Research Board, served chairman, Board of Institute of Advanced Studies in Science and Technology, Guwahati. He's also serving as member of Technical Advisory Committee of the Securities and Exchange Board of India. It is such a privilege, sir, to have been joined by you. I would request you now to share your views on today's topic, the role of Indian academia in the development of 6G for Atma Nirbhar Bharat. Thank you, sir.
Thank you. Thank you very much. So before I go to 6G, I think it is important to understand what is 5G and what India has done in 5G and what we really need to do going forward, So let me just share some 2-3 slides, and that will give you some perspective on sort of where we are in terms of, can I share the, yeah, all right. So I think you can see my slides, right? Yeah. So
Yes, we can see.
the 5G capabilities actually are quite. So let me just tell you that 5G is a paradigm shift than the previous generation technologies like 2G, 3G, 4G. This is not a time for me to get into the technical details of what that paradigm shift is. But just to understand that the capabilities of the 5G are going to be a very high spectral efficiency, which is like 30 bits per second per hertz, which means, you can get data rate of several gigabits per second. And you can get an enhanced mobility support of 500 kilometers per hour. Plus, in terms of machine-to-machine communications, you can really connect a very large number of devices like, several million devices in a small area. So I think these are really the capabilities of the 5G systems. Now, if you look at the international landscape, and this is what it shows that the major, see, if you look at the wireless communication industry is very heavily standards driven and the IPR driven. And therefore, it is important to understand sort of this slide. And this slide shows the contribution in 3GPP, which is a body which develops the specifications for the next generation wireless standards, and they come in various releases. So, for example, the 5G is release 16 or 15 and 16 releases, and previous generation LTE 4G were release 10, release 11, 12. So if you look at the standards participation, the India has very minimum standards participations, from the Indian side. On the other hand, large participation is happening from Europe and the China. And if you look at, in terms of patents, so if you look at this graph, you will see that in the 2G technology, 90% of the intellectual property rights were held by US and Europe, and only maybe 10% by the Asian countries. And if you see when the technology evolved to 3G, gradually the contributions of the Asian IPRs increased to 20%. And when it became 4G, almost 30% IPRs were held by the Asian countries, and that is primarily China, Japan, South Korea, and Taiwan. And now, if you look at 5G, you can see the graph has actually reversed now. That almost 65% of the intellectual property and the standards essential patents are now held by the Asia. And among the Asia, China actually owns a much larger percentage of the standards essential patents. So this shift has taken place, in the standards essential patent from US, Europe to the Asia. And this is very, very significant from our context because India still has a very, very marginal play, and we did make some contributions to 5G, and I will just show. And in this context, I think we have a very significant role to play as an academia and also, as a country, because you can now see that beyond 5G, the technologies are going to be all pervasive technology in an increasingly digitally connected world. And therefore, it is not just a question of holding the IPRs. Ownership of these technologies is basically going to determine the economic sovereignty and the digital sovereignty of the countries as well. And that is where I think, it is really important in this context. So standards, so therefore, we really need to do, now, given the fact that India does not have a large ecosystem of Indian industries and companies which are doing research, which is leading to the IPRs in the standards, we really need to focus on the standards-driven research and innovations in the academia. And why it is that? Because the reliance on the communication services are increasing. 5G and beyond technologies, now 6G will touch almost all aspects of our life. And the IPR ownership, as I already mentioned, will dictate the economic and the national sovereignty, and the countries which will control these cyber physical systems, which is like 5G, 6G, and AI, will actually control the world. And those who don't participate in standardization activities may be forced to use not so suitable technologies. And I will just give you one example in the Indian context, and I will finally close the remarks, by how we need to do it in the 6G. So you look at, a typical Indian rural scenario. So if you look at in India, relatively, sparse population, there is a low average revenue per user. In India, for example, we can only have 100 rupees per month. And we don't need very high speed mobility. If you look at, my 5G definitions here, 5G was talking of 500 kilometers per hour. In India, forget about rural areas, even in cities, we are not going beyond 40 kilometers per hour. So we really need very high throughput in India when we are stationary. Now, in the Western world, cellular mobile communication was developed primarily to address the problem of mobility. But in India, it has become a primary broadband access mechanism. So really, therefore, our requirement is that we need very high speed throughput. And when we are stationary, when we are sitting at home, or when we are working in the office, or rather than, looking at even 100 kilometers per hour or 200 kilometers per hour. Now, there is, of course, a trade-off in the communications theory. Something which is working at 200 kilometers per hour will obviously work when we are stationary, but with a very high energy cost. So there is always a trade-off between, energy and spectral efficiency. And that is why we really need to design the systems which are optimized for our requirements. So, the 5G, therefore, which was defined earlier, which was not so suitable for the rural India, because it was focused on, eMBB case. Also, the cell sizes were smaller. The intersite distances were much smaller in India. For example, in the rural case, we need, much large radius of the cell size. And as I mentioned, it was primarily driven by the needs of the major stakeholders, which were actually participating in the standards bodies. So Indian rural requirements were well not supported. And our requirements was, this was an original IMT requirement, cell radius of 1 kilometer, high-speed vehicles of 120 kilometers per hour in the rural areas, and in the urban areas, 500 kilometers per hour. Now, our requirement was a typical BharatNet infrastructure where the fiber terminates at the Gram Panchayat, and then in and around villages are connected through a cellular model. So our model, therefore, was that we wanted a intersite distance of 6 kilometers. That is, the cell radius should be 6 kilometers. And we wanted a scenario of indoor users with 3 kilometers per hour, outdoor users with 3 kilometers per hour, and in the cars, 30 kilometers per hour. So these were the configurations that we presented to the ITU, which was called low mobility large cell scenario, and which was to augment the original ITU IMT 2020 use case scenario. So this was presented after a lot of, techno-political battle. The LMLC was accepted in the IMT 2020. So this was a major breakthrough from the Indian community, particularly, as we had gone from the TSDSI, the Telecom Standards Development Society of India. As was mentioned in my introduction, I was a founding vice chairman and chairman of the TSDSI. So once this was accepted, so basically there was this urban eMBB case and the rural eMBB case. There was one configuration which was at 120 and 500 kilometers per hour. Finally, a configuration B, which was, configuration C, which was added, which was at intersite distance or cell radius of 6 kilometers per hour and 30 kilometers per hour. So low mobility, large cell requirements were accepted in October 2017, the meeting which was held in the ITU. And this was, as I mentioned, this was really a major breakthrough. Now, the key question then was that how do you now get it into the standards the requirements which actually fulfills the cellular case. So this work was done in the 3GPP standards, and in the 3GPP standards, through TSDSI, we tried to push certain waveforms and certain parameters, but obviously there was a stiff opposition. And then finally, from the TSDSI, we submitted our own radio interface specifications, which we called as 5GI, which 5G India. And interestingly, that got approved as one of the 5G technologies in IMT 2020 in February 2021. So when this was approved finally in December 2021, 3GPP agreed to incorporate the requirement, the IPRs which we had pushed into the 5GI as a part of the 3GPP standards only. And now in the release 17, we have those requirements. So this was a journey which went from requirements to innovations and standards, and we had a very large team from academia, from IIT Madras team, Professor Bhaskar Ramurthy and Radhakrishna Ganti from IIT Hyderabad, Professor Yubi Desai, Kiran Kuchi, Sai Dheeraj from the CVIT, Cluto and Priyanka, and from TSDSI, apart from me, Bhaskar Ramurthy, Kumar Shivarajan, A.K. Mittal, and Pamela. And of course, from the DST, we had, the senior leadership team up to the secretary level. So this was, one part. The other part, as a part of the IEEE standard, we are now leading this frugal 5G networks, IEEE P2061. This is another standard which is actually defining a network level architecture, and this network level architecture is basically very similar to LMLC, but this is not getting into the radio part, but this is actually at the network part. And this standard again is being led by our group, and 2061 standard will get approved sometime in this June or July timeframe. It is already gone for balloting. So and this will be for the first time that a standard will come out of the Indian academia efforts. In fact, the 2061 working group chair is one of my research scientists who has been working with me in our group. So this is what I would say is the story of the 5G. Now, let me just come, what are the possibilities that now emerge as a part of going beyond sort of 5G. So if you saw that in the 5G, we could get, our 5 to 10 IPRs into the standards. And in the IEEE 2061, we could get, again, our, 4 or 5 IPRs into the standards. And as you also saw that at the graph that I had shown, that now 65% of the 5G IPRs are held by the Asia Pacific country, which includes, the China, South Korea, Taiwan, and of course, we hold some 0.5 percentage or so. But there is an opportunity for us to influence, the beyond 5G standards, that is, the 6G standards, and, maybe beyond that. The work on the 6G standard has just begun. As you will see that in the 5G, the IMT 2020 requirements are already drafted, and when we got into, but we were successful in altering the requirements for the rural broadband case in October 2017. So that was really indeed a major breakthrough. But in terms of 6G, the work on defining the requirements has just begun. It is in the beginning stages. And once the requirements are frozen, that is IMT 2030, then the work on the standardization will begin. And finally, we are likely to see a 6G standard by around 2027 or 2028. So we still have about a 3-year horizon or a 3-year window where we can do a standards-based research and innovation and collaborate not only nationally but also globally to see that our intellectual property rights get into the standards, and as a nation and as a country we also get a certain pie of the global IPRs which are being held by the different countries. And as you can see now that from the 2G where 90% of the IPRs were held by the US and Europe, now that pie or that cake is sort of getting distributed, and it is therefore very prudent that India as a country which is now becoming from the second largest telecom market to now almost the single largest telecom market in the world, we actually start playing in terms of the IPR. So I just wanted to tell you one story that till about 2014 we could not contribute in 3G or 4G because India did not have the Telecom Standards Development Organization, which is the TSDSI. The TSDSI was set up in 2014, and I was the founding vice chair, and Kumar Shivarajan was from Tejas Networks, was the chairman of the TSDSI. And we became the 7th organizational partner of 3GPP. The 6 organizational partners were ETSI from Europe and from China, South Korea, US, and Japan. We became, the 7th organizational partner is TSDSI, and now it is possible for the Indian academia to participate in the 3GPP meetings through TSDSI. Because when the TSDSI was not there, it was not possible for the Indian academia and the Indian industry to participate in 3GPP because only members of organizational partners can contribute to such standard setting bodies. So with the formation of the TSDSI, this significant change has happened, and now as an Indian academia, we can actually contribute to sort of beyond 5G technologies. Now, as was mentioned that I just gave a use case of the rural broadband in the case of 5G. But in the next 4 to 5 years, as we will see the proliferation of increasing data usage and data consumption, more convergence of computing and communications, integration of various platforms like satellite, UAV, high altitude platforms. In fact, it is likely that we will have a very seamless connectivity with the broadband, not only with the cellular mobile communications, but also with the Wi-Fi, with the satellite, with the UAV, with the high altitude platforms. And we will also be integrating a large number of sensors, not only onto your mobile phones and watch, but also a large number of devices. So obviously, therefore, this is going to generate a significant amount of data. In fact, it is predicted that India is perhaps going to generate almost 300 exabytes of data annually. And this large size of the data really requires a new thinking in terms of developing a networking architecture, because the existing network architectures will not be able to handle that amount of data. Now, that again will be a problem very typical for India, because given the size of our country, given the population that we have, the potential for generating this significant amount of data is certainly there in our country, and therefore we really need to architect a new network architectural paradigm. In fact, our research group is currently working really on this problem, that how to design a scalable network architecture that can handle 300 hexabytes kind of data annually coming from large number of integrated devices, both in terms of sensors as well as from the user devices. And in fact, these kinds of data is not going to get generated from smaller countries like many of the countries of the Europe and so on. And in fact, that potential really exist when we will have a ubiquitous connectivity maybe in the next 4 or 5 years. And therefore, we believe that we should be ready for leading the design of a scalable network architecture, which is not only efficient from the point of view of large throughputs, but also which is efficient from the point of view of power consumptions and energy, because these networks are also going to generate large amount of, also going to consume large amount of power, and therefore we really need to design an energy efficient networking architectures. So I will stop here, and I will be happy to get into some interactions and questions, and if there are other views, I will be happy to listen to that as well. Thank you.
बहुत बहुत धन्यवाद सर आपका कि आपने अपने विचार हमसे साझा किए. For those profound insights that you shared on 6G, बिल्कुल ऐसे ही बनेगा एक आत्मनिर्भर भारत और एक नया भारत. आपके प्रोत्साहन के लिए धन्यवाद. I request Professor Ashutosh Sharma sir, if I can take some questions that are flashing on my screen now. Sir.
Yes, certainly. When we have a good expert, and it's a great opportunity for people to clarify any and all doubts. That's what IITs are for. And you have direct IITs, so this is great. Yeah, let people ask questions. And
Yes, sir.
right, yeah, go ahead.
So I'll go ahead with the first question, sir. This might be a little repetitive, but it is showing on my screen right now. So the first question is that as a renowned expert in the field of electrical engineering, what are your thoughts, sir, on the potential impact of wireless networking in transforming connectivity, and will it take up to 2025? This question comes from Rahul, a student of IIT Delhi, sir. Is here with us.
No, I think, of course, we are going to now see the proliferation of the wireless, both in terms of Wi-Fi connectivity as well as in terms of cellular mobile connectivity. And this, ubiquitous connectivity is definitely going to transform our daily lives, both in terms of enabling several digital applications in all sectors, and also in terms of improving our productivity by using very online tools in our work as well. So I mean, that definitely is, we will see that by next 2 years or so, when we have a widespread deployment of our 5G networks.
Right, sir. I'll go on to the next question, sir. How are there multiple opportunities and innovations by startups and MSMEs? This has come from Ankit from Indian School of Mines, Dhanbad.
Yeah, so I think so one fundamental thing that has happened after 4G in the 5G is that the 5G technologies are mostly software driven. In fact, till 4G, a lot of systems were like based on custom hardware and custom ASICs or VLSI chips. And now the 5G, of course, barring the RF front end and the antennas and amplifiers, which of course have to be hardware, the entire intelligence is now written through the softwares on general purpose computers, computing kind of hardwares and general purpose processors. So given sort of this shift that has taken place, India as a country, and in India, the startups and MSMEs can really take a sort of a leapfrog approach in this, because given that we are very strong in the software development, it will be sort of possible to quickly get into the technology development of 5G and beyond 5G and 6G kind of technologies, because increasingly, we have softwareized the network. So in this softwareized networks, we have a lot of possibility. That is number one. Number two is uh, all the innovations and interesting ideas that our startups and MSME are working on. I will urge them to become, if they are not already, a member of TSDSI, and through TSDSI, start making contributions at the global level and the global standards. So that way, I think we can get our IPRs into the global standards. So I think that both these opportunities sort of exist for us. And given the size of the market that we have, we need, there is an opportunity for a large number of players to coexist here. And given our country's emphasis now on developing indigenous technology and becoming Atma Nirbhar Bharat, there is indeed a lot of opportunity for homegrown technologies to get deployed in the country.
Yes, sir. Moving on to the next question, sir. Could you share any specific use cases or applications where 6G networks are expected to have a significant impact? Any use cases, sir?
Yeah, so I
This
think
question has come from Nisha, a student of IIT Surat.
yeah. So I think one of the biggest use cases of 6G is going to be the integration of all radio access technologies and sensors in a seamless fashion. And these radio access technologies will also include, as I mentioned, the satellite broadband and the broadband which can be delivered through high altitude platforms and UAVs as well. So the 6G, the biggest 6G use case will be the technology for providing a universal digital connectivity, where whether they are sensors or whether they are cellular towers or Wi-Fi, or whether they are satellite communications. So I think this would be, I would say, a very big sort of use case.
Sir, the next question, sir. What challenges do you foresee in the deployment of these 6G networks, and what steps should be taken by academia, industry, and policymakers to address these challenges? ये कौन सी चुनौतियां हैं? This question has come from Ravi from Tata Institute of Social Sciences, Mumbai, sir.
Yeah, so I think there are both, technology challenges and business challenges. In terms of technology challenges, we, as I mentioned, that we need ownership of the technology, and therefore, we have to get into the standards, etc. The other challenges are, availability of the spectrum. And in fact, as a spectrum policy task force in 6G, we have given many recommendations to the DOT to make available a sizable chunk of the spectrum in different bands for 6G. The third technological challenge is that, as I mentioned, that once you start generating large amount of data, you need a scalable network architecture and a backhaul, because ultimately, this data needs to be backhauled and get connected to the internet. So you need to enhance the capacity, not only at the radio level, but also at the backhaul level. So these are some of the technological challenges. There are business challenges because, and those business challenges are even there in 5G, because these requires, every technology evolution requires a new phone and a new device and a new base stations. So obviously you need significant investment, both by the operators as well as by the users. And for the operators to make such continuous investment, they obviously need return on investments, and therefore they will make such investments only if there is a very solid business case on that. And therefore we really need to have some innovative business cases which can sort of bring the return on investments, and so that the operators can make those huge investments that are required in deploying the technology.
Sir, one last question because we're running out of time, sir. Are there any notable collaborations or partnerships that India is involved with other industry players globally? This question comes from Vikram, a student at National Law School, India. And he's also asked one more question, sir. What are the spectrum bands, the new ones that are coming up? Or is it going to be built on this one?
Yeah, so I think, so let me just answer the spectrum band question. So the new bands in 5G, of course, we have many new bands like millimeter waves, etc. And in 6G, apart from the standard bands like, sub 6 gigahertz and millimeter wave, we are likely to be working on exploring the possibility of 95 gigahertz band, terahertz band as well. So which are really completely new band, unexplored band, and also has many technology challenges. But large amount of bandwidth and spectrum is available, and that is why those new bands like millimeter wave bands and 100 gigahertz bands will be explored. Regarding the collaborations, yes, I think we have been collaborating, and without those collaborations, it is not possible to get your IPRs into the global standard. So we have to compete at the same time collaborate. So this is being done with a spirit of compete and collaborate. So as I mentioned that that is how we could agree. We could make 3GPP agree to incorporate some of the IPRs as a part of their standards. So we definitely don't want to work in isolation. We don't want to have a India specific standards only for India, because we really cannot have the technology which only works in India. It will be ideal that we get our IPRs into the global standards, so that the economies of scale would mean that the cost of the products or the technology will come down. So we don't want to have a India 6G standard, but what we want to have Indian contributions into a global 6G standards. So that's where we need to work, and that is possible only we work and collaborate with the global bodies, but at the same time compete with them in terms of pushing our patents and ideas into the standards. So I think that's how this is.
With this, we come to an end of the question answer round. Professor Sharma sir, would you like to add something here?
Now that the future looks very bright with 6G, everything gets connected. We're all happy. All our stuff here has got intelligence and working for us. Together with computing and fast communication, dependable communication, inexpensive communication, communication everywhere, and computing everywhere. This is is going to bring many new opportunities. New skills will be required, but these are very exciting times indeed. And I want to thank again Dr. Karendikar for being with us, and Dr. Nidhi Kumar for running this show very well, and everybody who could join us for this journey. Is great having you here. Thank you very much.
Thank you. Thank you.
And on that note, I thank Professor Ashutosh Sharma, President INSA, and our keynote speaker today, Professor Abhay Karandikar, for sharing his vision of the role of Indian academia in the development of 6G. We request you to join us for more such sessions, as questions are still pouring in, but we need to close now due to paucity of time. I thank the audience and all the fellows of the Indian Science Academy and other fellow institutions for watching. India has a transformative potential, friends, of technology in addressing global challenges. With a focus on innovation, sustainability, and inclusivity, we can leverage science to drive economic growth, improve quality of life, and build a more equitable and resilient future. And to achieve this vision, we must seize the opportunities in emerging areas of growth like 6G and harness the power of technological disruption. India's ability to lead and drive these sunrise sectors of growth is critical to our sustained advancement of job creation, and the world and India cannot afford to lose this fight. It is imperative that we stand together. On behalf of Indian National Science Academy, I thank all of you for joining us for this very, very interesting conversation. Thank you, Professor Sharma, for letting this happen.
Thank you.